Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning at Databricks. And today I am joined by my co-host.
Ben Wilson. I do PR reviews at Databricks.
And you're so good at it, it blows my mind every time I see one. So today we have Fernando, and he was a guest on episode 89, during which we focused on software engineering, algorithms, and just generally developing skills. His background is as an ML engineer and also an MLT manager, but most recently he joined Google as an AI engineer, and he specifically focuses on LLMs and computer vision. So, Fernando, before we kicked off the recording, we were discussing sort of the transition to Google's scale. How has that been?
Hey, Michael, hey, man. It's been crazy. It's been, as we were discussing previously, my background is based on just jumping between different startups. And now that I joined Google, the problems that we are solving here are pretty much different. So in theory, are sort of the same. We train models, we deploy models, but the scale is the difference. So it's been pretty funny because this is something that I really wanted when I started my career, but I needed to prepare a lot. So um, um, I couldn't even imagine how the difference is when you are working inside Google, because you only see Google from outside. So working inside is pretty different. But yeah, it's been very different in comparison with the startups. The scale is the key point that I can say that is what makes the difference. Scale, yeah.
Yeah, there's definitely this at least stereotype in business where from the outside everything looks great, things are moving along, you're hitting your revenue targets, and then on the inside it's absolute chaos. There's just people yelling at each other, and of course Databricks is never like that, but uh, there are lots of examples where that is the case. So yeah, it definitely makes sense that there would be a different external perception to what actually happens inside. But sort of drilling into that scale question, uh, I'm sure you have a lot more different use cases, but for like the same use cases, is it the size of the models? Is it the amount of data? Is it the amount of users? What do you talk about when, or what do you think about when we're talking about scale?
Everything. Yeah, everything. I will explain, like, yeah, some specific points. The models, for example, at least in the models I've been, um, yeah, the models I trained in the past for these startups based problems. Um, we were trying to build models with some sort of data, like I don't know, thousands of rows, but we were just like trying to deploy the model for one endpoint to serve some I would say, like, imaginary users. Like we were going to spec, like, um I don't know, 1,000 requests per day or something like that. But we didn't even have those users. Just we were guessing that those users were going to use our model. Um, but in this side, working Google, we have the users, we have the data, we have, yeah, millions and millions of stuff. So you cannot just say, like, okay, maybe I will need to retrain the model because I want to see my result quickly, and then if it goes well, I will replace my model, because you do that in startups. Is like something like that. Here is not like this is not the case here. You need to be very careful with the suggestions that you make, with next steps that you are suggesting. And when you say, yes, I can do it for one day, in 2 days, you need to be very responsible that it will be done in 1 or 2 days. Obviously, there are some sort of, like, bandwidth. You're expecting, like, okay, took me like 3 days or so, but the difference is like that. Yeah, you have, the models are complex. We have ton of tools to use. We have ton of technologies distributed, millions of users. So this is the scale that we handle here in collaboration with what we had in startup. So yes, yes. I have here like I've been here in Google for the last 7 months, 6 months or so. So I am just let's say starting here. I'm just sort of new here. I'm still a noodler, how they call us. Um, but yeah, I think um, I still need to learn a lot in all the time that I will be here.
I've got a sort of a meta question for you about this.
Yep.
As somebody who has done something similar to what you've done, which is go from a company that's using ML that when you're building it and you're thinking about, oh, we've got 100,000 customers and whoa, we got 100 requests in the last 10 minutes. And when you're building something like that, you're sort of in that bubble world of scale. So 100 requests in a minute seems a lot. And then moving from that to deploying a model where you're like, hey, we've got 2.5 million requests a second to this endpoint. And this is a big deal. And there's a lot of infrastructure that goes around that. A lot of thought and engineering has gone into supporting a system like that. Do you find that there's advice that you would give to somebody who's making the opposite move direction about ML? So say they finish their PhD, they go straight into Google at that scale, and then they go on to a startup. And if they go in there and they're like, hey, I got to deploy a model, I have to build it Google style because that's what they know. Do you think that's effective in a startup to have to build infrastructure and use complex tooling to support, 100 requests an hour? And what advice would you give to somebody who's making that move?
Um, my first advice will be like ask for such a great compensation. First of all, uh, second, the first one was a joke. Second, I think hmm, I think it could be a good move, but yes, with the warning that in startups, at least in my experience, you need to provide that you're building something to attend thousands, millions of users, only to provide to your investors that you are doing that stuff, even though you don't really have the user, you don't really need it at that time, but you need to provide to your investors that I use the money you gave me, and I have built this pretty expensive stuff, MLs, endpoints, APIs, a lot of engineers with the money that you gave me. So we have that in startups. I think we have now that obviously in Google. We have another like metrics or something like that. I don't know how to say it, but in startups it's like that. You need to like say that you're going to build something really big, and you have trained model. You can attend thousands of requests per minute because you need to make happy your investors. So I think that is the difference. And in conclusion, my advice will be like uh, half joke, half no joke. Ask for a great compensation. Second of all, you need to keep in mind that you are going to be required to build things only to make happy the investors. And second of all, enjoy the freedom that you will have. And you have the Google guidelines to build things, but then you put your like your feeling on that, or your style on the work you're doing. So yeah, that would be my advices. Yeah.
Ben, if you could redo your career, would you start off at a Google or would you start off at a startup?
Oh,
And Fernando too, yeah. I'm curious for both of you.
okay, okay.
I mean, my career started in nuclear engineering, so that was pretty much a waste of time. Um,
Oh, really?
but I mean, I did so many different things in different industries, so I don't think I would change any of it because it forces me to think of things differently. But if we were to just take the last 15 years and say, hey, when you started messing around with software and ML and learning data science, um, I don't think I would change it either because I learned better by like doing dumb things and then figuring out how much I messed up. That resonates in my memory a lot better than learning the right way to do something and then being put in an environment that is so foreign to how I did things before. I think that would frustrate me. Like if I started with the rigor of a large tech company that had a lot of stuff figured out, and I wasn't involved in seeing that stuff built, not saying like, oh, I need to be the one building it. It's more like, I just want to see what it was like before. Then some smart person came in and built this tool, and then I start using it. I'm like, man, this is awesome. And I, you get an appreciation for why it was built and what the impact was. But if you come in somewhere and everything already works, I mean, there's always problems, Fernando. I'm sure you can confirm, even at a massive tech company, there's always stuff to work on, right? And nobody has perfection in what they're doing. But going from someplace that largely has most things figured out to pure green field where it's like, here's a platform you can run your stuff on and use whatever you want from the open source community or build your own if that doesn't exist. I think that's overwhelming a bit. I think it would lead you to over engineering. It would lead me to over engineering stuff.
What's your take, Fernando?
Oh, with the question that you ask at the beginning,
Yes.
like, okay, Uh, okay. I think, um, yeah, I think, I don't know. In my case, I would prefer to learn first in startups, like learning, um, have freedom to learn, to make mistakes. But also, I'm not sure because I see my peers that are how to say it properly, some juniors in Google, and I see them and I see them happy. um, so I don't know, maybe the path that they will take, it could be, in my opinion, a happy path because they have started from the beginning in Google, so they are learning just step by step all the Google guidelines. In my case, I started I as a almost a senior level, so the expectation on me is pretty high. I know some things, but some of the things I know are in theory, but I have never applied it like in real life. And here the expectation is that somehow I had experience or the knowledge how to do it in real life, in real and in scale problems. So I think that is something that I would prefer change, like being started from the beginning, because from the beginning I would have the experience learning step by step and then growing. Yeah, so I don't know if you got my point, but now that I have entered in this level, the expectation on me is like I will behave as a senior or something. But some of part of my experience proves that I have the level, but for some specific topics, I have not that much experience, so I need to learn quickly and to be aligned with the other engineers. And I think these other engineers might be those that have started from the beginning in Google. So I need to like align my level with the others. Yeah.
Um,
So yeah.
this is a topic that I'd love to dive into, actually. Uh, you're talking about imposter syndrome, which exists everywhere. I've personally interacted with people that have been hired at Databricks in our department who are senior staff engineers, and within their first 4 or 5 months, just talking to them and asking them questions like, hey, how's everything going? How are you enjoying it here? And almost uniformly, all of them kind of get a look on their face. They're like, I'm overwhelmed. Uh, there's so much stuff that has been built here. There's so many processes, and they're like, just looking at the build infrastructure. They come from another big tech giant, and they're using similar tools, but like what we're building is fundamentally different. So learning a whole new tech stack, and then learning about the differences in product development and the velocity. It's just different wherever you go. Like some places it's like move fast, fail fast, correct fast, and just go, go, go. Other places are more lots of upfront planning, making sure that prototypes work, and you do all your homework beforehand, and then you get into development mode, and then you have like a mix between those two. But that imposter syndrome, I think everybody shares that when you start working in engineering in a big tech company. Everybody's like, man, am I the dumbest person here? Like, I don't get what's going on. And I've met it at every level. And the only solution that I've found for that is open communication amongst engineers. People just admitting, like, yeah, I have no clue what's going on. Can somebody explain this to me? The number of times that I've seen the EL15, explain it like I'm 5, right? On a comment on something, even from principal or distinguished engineers, they'll leave that comment in a design. And you're like, huh, they realize that this is too complex and we need to make it simpler. But they're not afraid to say that. And when you start seeing that, you're like, huh, okay, I'm not the only one. Sweet.
Yeah.
Yeah, it's interesting that you bring that up. I've been an imposter my whole life, like
Oh my
since
God.
like in school, I was not always the what's the word? Like I went to a very prestigious school, and everybody around me I felt was smarter, specifically in the technical space. Like you had the mathletes that had done combinatorics since they were 7 years old and can like take the square root of any prime number up to 10 billion. And I was just not like that. I played a lot of sports in school. I hung out with my friends a lot, played video games, of course. And so I'm starting to get to the point where that just feels normal. And it's actually kind of cool. Like I just being around people where I'm just like, yeah, you could whoop my ass in like 90 of these technical fields. And that just is starting to feel right. Um, it's actually sort of interesting as I'm sort of discovering it as I'm saying it. Do you guys still get sort of self-conscious about it, or is it sort of a comforting feeling when you're feeling like an imposter?
Um, Let me think.
Yeah, what a thought-provoking question. I don't get bothered by that. I mean, I think I've moved on from the imposter syndrome and worrying about that so much. It's just gone to acceptance of knowing that
Yeah.
it doesn't do me any benefit to feel like I'm inadequate because I don't understand something. It's just it's like I've short circuited that pathway in my brain to be like, I don't know this. I need to learn this, or I need to figure this out because I have a task that needs to be done in the next month. So I know how to get those answers and make sure that I understand it in the way that I understand things in the fastest way possible. And then learning to ignore everything that I really don't need to know. And that fire hose of knowledge that can come when you're like, okay, it's the start of a new fiscal year or start of a new quarter. What are all the things that we're all like everybody's working on? As an outsider, you'd probably look at that and be like, I want to learn all this stuff. I want to understand what's going on. But as somebody who's responsible for building a part of that, uh, or guiding a team in building that, you're just like, I cannot pay attention to that other stuff. or worry about it. Like there's really smart people who are going to solve that, and I can't wait to use what they're going to build because it's going to be awesome. But I need to focus on understanding the problem space that I'm working on as best I can so that I can do my role in the development of what we're responsible for. So it's just not worrying about like within Databricks, right? Like I don't worry about what's going on with Delta or Unity Catalog or unless we have to integrate with it. And then I don't need to understand everything about that. I need to understand who do I need to ask, who's going to point me in the direction so that I can learn what I need to know about this before making technical decisions.
So like focused excellence and not worrying about things out of your purview.
Because otherwise, everything's a distraction. I think
Yeah.
it's overwhelming. It's just too much
Yes.
information.
Yeah.
How do you think about it, Fernando?
Yeah. In my case, let me know what you think, guys. In my case, is I'm not conscious that I have the imposter syndrome. I only I'm aware of it when I look back and I analyze my picture like, something happened there. I act in this way, uh, in this situation, so on and so forth. So at that moment, I realized like, okay, something weird is happening that is maybe called imposter syndrome. But in the moment, in the loop, I am not like aware, like, oh, I'm facing that part. I feel like stress, I feel worried, etc. I'm just like a hard worker, and I would prefer be a smart worker. I am a hard worker because if I have a problem, I'm just focusing on like how can I solve this problem, and if something, um, I try to like, I don't know, touch all the possibility uh, before I contact someone for making like, okay, can you give me a hand? I don't understand this. I'm pushed inside Google to to do the opposite, to like as Ben said, like if I cannot handle this, I not understand this. Instead of like being overwhelmed with the problem by itself, I need to first ask with some guys in the channel we have, and someone will reply, someone with provide some guide like, hey, look at this documentation, look at that, etc. So my point is like I'm not aware of that imposter syndrome when I am in it. Only when I look back and I analyze my past and I say like, okay, and I'm aware of that. Like when I'm saying like I'm a hard worker, but I prefer to be a smart worker, and yeah, so that is my feeling. But there are many phases of this problem because on the other side, I really enjoy and really passionate with the problem by itself. So for example, now I'm working on GPU optimization. I mean, looking at how the operations go from CPUs to GPUs, how do you optimize kernel launch times, so on and so forth. So suddenly I got passionate about it, and I just focus on this problem. But sometimes I found, I don't know, some blockers, and instead of go with someone from, I don't know, the TensorFlow team, the Keras team, or someone, I try to go to the documentation, read the entire documentation, and see where was my question to be solved. So where is the solution to my question? So this is the way that I do. But in the smarter way, I think it would be better like going to those experts and ask like, I have this problem, um, where can I go? Well, so something like you see my point, right?
I would ask you, Michael, but I think I already know the answer. Are you a hard worker or a smart worker?
Both.
Of course, both. I'm a perfect worker. Um, I am naturally inclined to be a hard worker, and I'm aware of that. And I try to be a smart worker when I can. But my style is like smashing my head through a wall. It's not walking around the wall. and I need to get better at walking around the wall. And that's actually been something that I've been focusing on, and I'm a lot better at it now. But there's something satisfying. At least the psychology for me is I see a problem, I'm like, all right, this is not too bad. I try to solve it, I fail, and then I get interested. If I can solve it on the first iteration, it's not that satisfying to me. And so, but
This is
that
boring.
yeah, exactly. But there's a dangerous loop to that. It's a slippery slope. Like on the 70th iteration, you're like, oh, it's going to be so satisfying, but you're just so far away from the potential set of solutions that you just are not going to do it, and then you like go and cry. But if you had asked on like the 7th iteration for steering, that's typically optimal for me. What about you guys?
I mean, I would agree with your self-assessment and how that's changing over time as well. And one thing I've noticed after talking to thousands and thousands of ML professionals in industries, either one-on-one on this podcast or, when I was working with ML teams in the field at Databricks, is that whole work harder instead of work smarter is sort of the defining characteristic for really good data scientists and ML engineers, because that methodology is the most effective approach to solving machine learning problems. Of saying, I'm going to approach this in a scientific method. I have a bunch of hypotheses I need to test out, whether it's just an idea of, hey, I think this should work this way. Let me test it. And that's sometimes applied to framework code, like not even stuff that's involving training models or constructing an architecture for a model. So it's sometimes data scientists take longer to write, boilerplate code and stuff because we're conditioned, or maybe it's just who we are working in that role, to try to brute force our way through and test a bunch of stuff and then see what's the most promising result, and then iterate and make it better, and then finally you have a product. Whereas pure software engineering is the exact opposite. It's more like plan, intelligently think about the solution, get peer review, ask questions, and get that optimal answer as quickly as possible, and then to go and build it. And that's why I think for you, Michael, you're seeing that transition in yourself, because you're making that conscious decision to be like, I'm thinking about things differently. I noticed it myself when I did that exact transition, where I'm like, yeah, I approach things way differently now because of needs of velocity, product development lifecycle, and the type of, like, the nature and type of what I'm working on now is rapid iteration, and you just I can't do that old way of how I used to build things.
Yeah. Fernando, I know you have, at least from the outside, it seems like you have a very strong work ethic, and you spent a lot of time building up those skills via like leak code or whatever it might be, practicing algorithm implementation. What do you think are the non-technical things you gain from those exercises?
Could you repeat your question, please?
Yeah. So you spent some amount of years, like in a lot of your free time, working very hard on the technical. So obviously now you can implement a sorting algorithm or whatever it might be. You know your light GBM versus XGBoost versus random forests. And I'm curious what all of that hard work has given you from a non-technical perspective. So, do you have a better work ethic? Are you better at understanding your limits? Are you better at planning out how long something will take? Are you better at prototyping? What are the things that you gain from all of those years of hard work that are not learning how to implement an algorithm?
Yeah, I got it. Uh, I think I think I feel better prototyping because I think I can move fast building like POCs. You need to prove how this tool will work. I can do quickly. Um, and yeah, I think that is the only thing that I gain. Because, for example, with lead code problems, um, as I said many times, the only thing that I learned besides have being really good on understanding how these problems has been like written, how to approach the interview, so on and so forth. It's like the understanding of the nature of these data structures. Something as simple as that. Just the natural. With natural, I mean like how do a hash map works, how do a link list works, how do so much more. So I think going back to your question, Michael, I think what I've learned, my skill that I work and now I feel better on it is prototyping. Um, this helps me, for example, when I start a new project, I need to build a POC here inside Google, and I can do quickly. The I don't know, the time we have is like 1 week. I can do it in 1 way, and I do not do many iterations. Like, okay, I did it in 1 day, but the next day I had to change like almost everything. No, it's like 1 day and just adding uh, minor things, and that's it. So I think I'm good on it. Actually, I got feedback from my peers about it. Like Fernando is like sort of the fast guy doing POCs and building code quick. So I'm aware of it. I like it. I feel like like an athlete that train a lot of time running whatever. Now he's able to run really fast in comparison to some others that did not train as hard as the one that trained almost every day. So this is a sort of analogy that I have. Um, but yeah, and also I think I was able to like I don't know how can we measure that, but um, the better understanding of the problems. Because before my hard training on ML and these legal problems, I was like overwhelmed with what the problem statement says in terms of machine learning. For example, you have always a problem in the description of the problem is always a problem in your real life. Like we have this amount of data that is related to some sort of population. So it was a context there, and it was like block in the terms like I don't know what to do. I don't know I don't know what to do. And then training over and over again in Kaggle, for example, I was able to sort of like quickly synthesize in my mind what I have to do in order to overcome these tasks. So yeah, I think that would be something similar to the first one that I mentioned. Yeah.
Yeah, one thing that stands out about your work ethic is that it creates a lot of confidence via reps. So, confidence is, I define it at least as sort of general certainty about your abilities. And if you've done something a bunch of times, well, you can go do it again. And so, the fact that you've done all these little mini prototypes, it's probably really, really useful when you're building let's say, a complex version of those prototypes with maybe 8 components like you said, you're fast to POC. If you have done each of those components a bunch of times, you're probably pretty confident about building them. And then also because of that, you can assemble them really nicely. So you essentially have like a lot of raw building blocks that are very solid that you can insert wherever you need. Does that
Yep.
make sense?
Yep. And also one drawback, an important drawback, is the one that I mentioned at the beginning of this conversation. Working at a scale, because I think I'm the guy that is pretty good doing like these POCs. But once you are moving to the part of making those scalable, taking care of how the user will going to use your tool, whatever, for me, it started becoming a little bit overwhelmed. Like I don't feel comfortable. Like pretty. I don't have the how to say that I don't feel pretty sure in comparison when I'm building POCs. I start feeling doubts, not feel confident, but I exchange ideas, I communicate with my peers, but I do not feel comfortable in comparison with what I'm building POCs. When I'm building POCs, I feel like a rock star. I don't know how it doesn't sound that. I hope it doesn't sound like
No, it doesn't.
But I feel good. I feel confident on it. But once I move into to a territory that is not my comfort zone, building POCs, I start losing my confidence.
Well, that's good, and that's also something you can't really learn from Kaggle. Like I will never forget the first time that I
Yes.
tried to run a SQL query against the table that was too big to run a SQL query against. And I was like, whoa, I could sit here for 7 weeks or I could sample the data. And that sort of inflection point, you can't really get, you can read it, you can hear me say it, you can hear someone else say it, but you need to experience it firsthand. It's like, why is this query taking 16 hours? And so I feel like you can't learn that outside of a large organization. Do you agree, or do you think you can potentially sort of intuit that from textbooks or anecdotal conversations?
That is a good one. And I think, yeah, totally biased in my experience. I think it's pretty difficult that you will learn these things outside large scale companies, because it is how I was doing it. I was learning from books and I was translating this knowledge in some blogs. And my blog says like how to deploy a model, wherever. But it's what the theory says. But when you're really working on these problems, it's pretty different. But it's not as the book says. So you need to, yeah, it's pretty different. You can say how to deploy, how to make Docker container, how to deploy your Docker container, and this sounds good. You are deploying something, but doing this for large scales problems, it's pretty different. You need to consider many factors, a lot of factors that you weren't aware when I was writing my blog, like how to deploy a model, blah 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 blah. So I think you the only way, um, in my experience, the only way you can learn these things and have experience on it is working on a large scale company, wherever the company is, just large scale company. Because again, working in startups, I work a lot of times in startups, and I realized that I was I work hard. I was doing my job, but I was always curious about how to do this in real scale, like in big scale. So I was a guy like was looking at tools to put your models in large scale. So at one point when MLflow was launched, I was a guy who says like, hey, there is a tool that we can use for versioning your models and deploying, see whatever the metrics and with plenty of models. But we had not the plenty of models. We had not the data. It was useless for our case, but I was like the guy who was trying to see like how this problem will be handled in large scale. So it was the young Fernando thinking, living like I don't know 6 7 years ago. But yeah, in conclusion, my conclusion is yeah, the only way to learn these large scale things is working in a large scale company, and you can learn, read a lot of books. You will have the theory, but in real life you will need to communicate with different departments. The things that are not in the book, that are not, yeah, mentioned in that book, you will need to make agreements with your peers. You need to, yeah, there are a lot of things that you need to consider when you're working in large scale companies.
Yeah, I can I can say from my time at smaller companies that didn't have a large ML presence and the teams that I was in, I was able to ship prototype code to production. Write tests and stuff. It wasn't like junk code that was being shipped, but you don't have to worry about things like scale because it's like, hey, we need to retrain the model every 2 weeks, and then if we want to replace the model, it's just like you said before. It's like, let's just test it offline with production data that's coming in. Does it look good? Let's run it through some statistical tests. Let's compare it to what's currently in production. That's just analytic notebooks. I was doing that stuff in Jupyter, and you get an analytic report from some, you know, boilerplate analytics code that you wrote with matplotlib, and you're like, yeah, this looks good. Look at my my t-test results here. I'm good. Let's switch it off. Let's turn it on and shut production off. Make sure that traffic is going through it. And for me, the biggest thing that opened my eyes was working with a couple of the customers at in my first few months of working at Databricks in the field, where some of these customers, they're not household names. And you go into their office and you're like, okay, it's like a 50-person company. I'd classify that as, startup size. And then you look at their data and you're like, hang on, this is geofence data for an entire cell provider that your app is installed on. How many trillions of rows is this per day? They're like, oh yeah, we get like exabytes of data per month coming in. And you're like, what do you do with all that data? They're like, oh, we build models off of it. And I was like, what kind of models? Like, they're like, oh, we write the algorithms ourselves in C++. And then, they're compiled binaries that we're, using for deployment, but we do all of our analytics and feature engineering on Databricks. I was like, that's cool. But why do you use C++? And they're like, big O. I'm like, oh, so yeah, at that scale, this actually does matter. And it gave me an appreciation, particularly in the feature engineering stage. And that was the light bulb that went on my head. Like algorithmic efficiency and data structure, particularly with traversals, you start to really get a true appreciation for what that stuff means. Because the computational time complexity with most things where you're like, oh, should I use a loop or a comprehension, makes sense to like map over it. But then when you start talking about these data structures, why we go through an algorithms interview, it becomes apparent when you're like, oh, that's why we use a hash map here. When it doesn't matter when you're storing 100,000 items, it's almost instantaneous. But when you're storing 100 billion items and you need to drive to, the difference between log n and n becomes very apparent very quickly. That was a big shift for me. Like seeing that, and then also the concept of staging, where you're not just testing in dev, of saying like, does my code work? Does this solve the problem? I'm going to fetch some prod data and then do an offline test to make sure that everything's working. It's more like, I need to test this at production scale with junk data just to make sure that the service doesn't blow up.
Yeah, Fernando, do you feel prepared for learning these big data concepts from your training? Or do you think that you would have liked to have taken a class or read a book before joining? Or gotten a PhD?
I'm not sure. I would prefer just jump directly to the stuff, big data, and then be learning on the fly.
Cool.
Yeah.
Yeah, same here. I definitely think that the fastest way to absorb knowledge is just like jumping head first. It's definitely the most painful way. And some
Yes.
people can really like excel in classroom settings. But for me, my main issue is twofold. It's interest. Like I don't care about the theoretical example with the clean data. I want to see like the real data and have this turn into a real use case that's actually deployed in production. And then also for me, retention is not a strength of mine, I would say. Um, I'm very dynamic when put on a new problem, and I remember where things are, but I don't like if you ask me to explain how any algorithm works, I could do it at a high level, but I don't know that I could recount it from memory that well. Ben and Fernando, in your guys' experience, like I know Ben, your brain is a Rolodex, um, but for both of you, do you guys think you are strong in terms of maintaining memory of complex systems, or how do you guys think about memorizing facts? Like, how's your brain structured?
For me, I don't even know, man. Like I've had people ask that after I've spoken up during like design reviews and stuff, or I made a comment. Somebody's like, "Why did you even ask that?" And I'm like, "Oh, it's because of this." And they're like, "Wow, boy, we didn't even think of that. Thanks for bringing that up." Um,
Funny you say that. Actually, I was working with a data scientist like a month back, and they were like, "Oh yeah, I have to go do this podcast with Ben." And they were like, "Oh, Ben Wilson, yeah, he's a fountain of knowledge." So congratulations about that.
fountain of knowledge, fountain of BS. Um, I don't know how like why I retain certain things. I think most of the stuff that I will speak up about and not just tell my brain to shut up and like don't leave a comment on something. Particularly, I'm talking about like implementation design reviews and stuff, which is where that knowledge it becomes useful, or during like a code review. Um, the stuff that I am aware of me regurgitating from memory is usually stuff that I screwed up. So I'm bringing it up not because I'm like, you didn't think of this and you should have thought of that. It's like, hey, this burned me like 5 years ago. Can we just look at this? Because this could potentially be something bad. And I don't want you to fail the same way I did. And sometimes it's legit. And somebody's like, yeah, we definitely need to clean up the state of this because there's a memory leak here. Or it's, no, we have this other mechanism. Or, no, this process is going to be killed. We don't have to worry about that. And I didn't have context for that other part of it, or it's part of the system that they're working on. I didn't know it was there. And it's like, cool, great. Thanks for looking at it. We're good to go. Or sometimes it's, oh geez, we need to rethink this. Let's use this other data structure, or let's use this, complementary process that will do stuff like flush a queue. If it starts growing, it's use TTL. Like there's lots of things to think about with scale that you don't have to when you're, working on smaller problems.
Cool.
You didn't answer the question. The question is how is information organized in your brain? And I guess you did answer the
I
question
think that did
partially.
answer the question.
Yeah.
It's not organized, which is why I pointedly didn't answer the question. No, I really don't know. It just
It's just there.
when I see something that when I process that topic, it just pops up through some quantum event of like, hey, remember how stupid you were back here at this time? And I'll remember that and then write, you know, transcribe like, hey, we should think about this.
So
Maybe.
Yeah.
got it. So your cache is optimized for emotional connection to that fact.
Oh yeah, definitely. It's
Yeah.
about all the hubris checks I've had throughout my career, even before software. Like me thinking like, yeah, I know this. I understand this, this concept, and then find out like, hey, you remember that nuclear evaluation board that you went through and the that NRC investigator who asked you that question that almost got you disqualified for your terrible answer? Think before you open your mouth. So like stuff like that just sticks with me.
Got it. What sticks for you,
Uh,
Fernando?
Um, I think sort of like similar Sven does, but I would say like in my case is when I started learning stuff, different stuff. I try to change instead of learning the what, learning the how. Like for example, what is TensorFlow? I don't want to memorize what is TensorFlow, what is something. I want to learn how TensorFlow works, like in this scenario under this context, how linked lists works, how a decision tree works, instead of think what is a decision tree. A decision tree is a sort of whatever. So when you change the how instead of the what, I think in my personal experience, it helps me to like conduct my knowledge in a more handled way for myself. So when I learn new things like how how Jax improves my code instead of TensorFlow, for example. So instead of being like, what is Jax? What is this new function? What is this whatever? It's like how this thing replace this. What how yeah, the how.
Can
I think
you
this is yeah.
could you walk us through an example? You shouted out a bunch of cool technologies, but could you show us a what and a how for maybe one of those or something else? Just a simple example.
Yeah, for example,
What is Jax? How use Jax? That would be a good one. I
yeah,
mean, it's new,
but
it's hot, it's pretty awesome, but low level, and yeah,
that
that'd
that
be a
is
good
a good
example.
one. That is a good one. For example, I don't wanna like say what is Jax? And Jax is a new framework like was developed by some guys. I didn't want to memorize it. I don't want to memorize like the manual. I want to find the things that I need and how those new things replace the things that I want to improve by using this new tool. So, for example, let's say I'm working with TensorFlow, with Keras, and I need to replace some piece of code to be optimized with Keras and with Jax. And since this is my first time with Jax, I don't want to learn what is Jax, what is this function, what is the way to make a math model with Jax. I want to learn how to take advantage of the different functions, operations that Jax provide in order to optimize my code. So when I change that mindset, now I think I learn a little bit faster, better, the new thing in this case, Jax, for example. So I don't know if my example is clear, but this is the way how I speak inside my mind the things in order to learn this new stuff. So yeah,
Is why relevant?
For me, yeah.
yeah, yeah. For example, why? But if you try to, my advice would be try to avoid the what. What is that thing? So I
Okay.
try. I think it's better to put into context the thing, like how the thing will improve, how the thing will help me, how the thing. I think in that mindset, it's better instead of think.
So how is what with context? Or it's like
Hmm.
with
How is an
context and
I
implementation?
think how is like an application of what, but divorced from pure reference knowledge of that thing. So if we're
Yeah.
talking about a software package, you you're talking about TensorFlow and Jax implementation. But if you were to shift to something like a tool that is more hierarchical, I guess, in nature and restrictive. So TensorFlow, you can do anything. But if you're to say, okay, let's talk about stats models, like what is stats models? You could memorize all of the different things you can do with that and all the different use cases for a package like that. That's not going to help you to build anything. It'll help you understand, should I use this or for these type of tasks? But understanding how to go through and understand the how to use this thing helps you build stuff faster. And I think the understanding the why it was built helps you understand whether you should use it or not. So if
Hmm.
it's got a compelling why this was built, people are probably using it and it's well maintained, it's probably well designed, it's somewhat easy to use, hopefully, and it proves valuable. Um, and if you look at something and are trying to figure out the why, particularly, this is what I do with hype stuff because I get sent hype stuff every week of like, hey, we should integrate with this new package with MLflow. I'm like, why? Uh, I don't ask them that, but they'll send me a link to a GitHub repo. And I'm like, cool. This was released 2 weeks ago. I have no idea who this person is. I don't know a lot of people in the software, you know, open source community, but I'll look through the code, like the source implementation. Usually start with the tests. I'll go into the test folder because that shows me the how really fast. and I'll look at what they're testing. I'm like, oh, that's what they're doing here. That's cool. Or I'll say like, why? Like, why does this exist? Search through a couple more tests. Like, isn't this XG boost with like a slightly different optimizer? Like, why does this exist? And if I can't get a justified reason for why this is a thing, I'll file it in my memory or leave a note for myself. Check back in 3 months. See, is there now 5,000 stars on this repo, and check PyPy download stats. Are they getting 100,000 downloads a week on this? Maybe they're onto something. Then maybe this is fundamentally better than what exists before for some reason. Better APIs, or it's faster. Who knows? For the other 99% of the time, though, if I ask that question, why, and I'm like, I don't know why this exists, it's usually junk. Move on. Not worth my time to understand.
And also, I would like to rephrase my first answer. And I would say, if I could sort the what, how, why, I think it's most important or most relevant first the why, understand why, and then the how, and then if it is the case, if you need it, the what. In this case of React, for example, why do I need React? Because it will help you to optimize your stuff. How? Using these compilers, using these things, whatever. And only if you need it, you learn the what. What is the function that I need? I need this function and this operation. But the whats are in the documents. The whats are in your documents, in bibliography or references. But I think it's the most important to learn the why, then the how, and only if you need it, the what's. So this is my conclusion of this.
I like
Couldn't
it.
agree more.
Yeah, if you just have this, like, think about a blob of a search space, the why narrows down the search space to the important things. Then from there, the how is the most efficient place to get from thing to prototype or thing to implementation. And then the what is sort of the filling in the knowledge around that prototype so you know that you're actually doing the right thing. And maybe we don't even need what. Like, we should just grunt at things and not use their names.
You need docs.
You do need docs.
You do need docs.
Yeah.
Because not everybody wants to do the self-discovery how.
That is true.
And I don't blame them. I mean, as now somebody who is responsible for maintaining docs on an open source project, and doing iterative project design for integration with other services or using other frameworks, I have a very strong preference and unspoken thanks to maintainers that spend a lot of time making good docs. So if I can if I can answer the how and the why in less than 2 minutes of going to their docs page, I have profound respect for the person that put in the effort, the unbelievable effort to answer those questions that quickly. I'm just like, man, what a great team of maintainers. And then sometimes you're like, hey, I know this package is important. It's like everybody's using it. Everybody's talking about it. I go to the docs and I instantly have that negative why experience. Like, why did they not spend at least some amount of time answering this question? Like, these docs are so terrible, and I don't care how powerful this tool is. Like, I now have to read your source code to understand how to use your tool. And then by read your source code, I mean, I need to find where the public APIs are in your source code because they're not self-documenting. And now I have to reverse engineer your implementation for your entire project. That pisses me off when that happens. So yeah, it makes finding the why harder.
So Fernando, before we close, do you have any tips for people who want to make a similar transition from, let's say, to the startup world into a large organization like Google? How did you do it, and how have you seen other people who took a similar path? How have they done it?
Yeah. First, my advice would be like um, study a lot in the way how you think is the best way for you. In my case, is like repetition is a correct word. I repeat it every single day, solving two, three problems for being able to be more like fast solving this sort of problems. But this is my case. If someone that hears the podcast is trying to do the same thing, uh, I could say first, like, try to identify how is the way that you learned the best. If you need to read books, read the books. If you need to practice a lot, practice a lot. In my case, it was practicing. And then try to think in scale. Try to yeah, try to think in scale, because real problems in real life works in scale. Um, and the second one, well, experience from some people I have met here in Google. Uh, pretty different stories. Some of them just were hired directly from the university, so they went directly to Google. So the happy path, how I call it. Um, but some of them have done some similar paths as I did, like practicing a lot, studying a lot, then passing interviews, and that's it. Um, yeah, my last advice would be like enjoy what you learn, enjoy everything, because um, one day you will be hired for a company you want, and you will be, I don't know, focus on other things like learning and trying to catch up as soon as possible in your projects, the tools that you're learning, the tools that you need for doing your job, and then that past of solving problems is just the past. Now you are in here, and you will need to learn another stuff and think what's next. So yeah,
Cool. Crystal clear.
yeah.
All right. Well, I will summarize. We had a lot of very non-technical topics, which I really enjoyed. It's fun to think about how to, like, the technical honestly is the easy part in a lot of cases, and it's building your brain so that it can work and scale out technical solutions. I think that's the hard part. Um,
Mm.
so some things that stood out to me was, first of all, transitioning from startups to a Google-like organization. In the startup world, you typically have to sort of pitch yourself more and pitch your products more. When you enter a Google type organization, you're given a very predefined role where you need to execute. And then, of course, the core difference is scale. So, data, users, infrastructure, everything. At Google and those types of organizations, there's just a lot more stuff in every aspect. Imposter syndrome is a real thing that everybody experiences, like legitimately everyone. But it's really good to communicate this. And if you're feeling it, someone else probably is too. And it's also important that you're a smart worker and you ask for help when you need it. Sometimes you can bang your head against the wall 50 times. And if you enjoy that, such as myself, feel free. But it's often more efficient to ask for a redirect or at least a shift in perspective. And then finally, on the learning side, focus on the how instead of what. And if you're going to prioritize the questions, first think about why, then think about how, and then finally think about what if you need it. Also, figure out your personal method for success of how your brain works and how you should be learning. And then finally, don't lose perspective. Enjoy where you're at now. Uh, grass is always greener on the other side. So when you've moved on from your current situation, there will always be things that you will miss. So, Fernando, if people want to learn more about you or any roles at Google potentially, where should they go?
My LinkedIn slash fair neutron, as it sounds, fair neutron. In all my my social network, like GitHub, even Instagram, I am like fair neutron. Yeah,
Do you mind spelling that out just for fun?
yeah. FERNEUTRON.
Cool. Awesome. All right.
So,
Well, until next time, it's been Michael Burke and my co-host,
Ben Wilson.
and have a good day, everyone.
We'll catch you next time.